Today we'll talk about what to do when you have a division problem that has a dividend or something that you're breaking apart with a decimal in it. Now let's think about that first example there. 9 3/10 divided by 3. What this is really saying is that I have 9 wholes and 3/10. There are my 9 wholes and there are my 3/10. And I want to break them up into 3 equal groups. So my divisor could either be I want to break them up into 3 equal groups, or I want to break them up into groups of 3. Kind of depends on the context. So here, if I were to break my wholes into 3 equal groups, I could say there's 1 equal group, 2, 3. They're equal because they each have 3 wholes in them. But I can't just break up my wholes, I also have to break up my parts. So I could say this 10th goes to this group, this 10th goes to my middle group, and this 3/10 goes to my 3rd group. So one way to do my division problem is to draw myself a picture. And I would say that there are 3 wholes and 1/10 in each group. Always a good idea to check your work with multiplication. 3 and 1/10 times 3 gives me 9 3/10. My divisor. Okay, so that is the correct answer. But problems aren't always easy to draw, especially when you have much larger numbers. So a way to do it with long division is to say your dividend goes inside, your divisor goes outside. For the sake of today, our divisors will only be whole numbers. Tomorrow we'll talk about what happens if your divisor is a decimal. But for today, we're going to say, here's my problem. Anytime I have a whole number divisor and then a decimal inside my house in my dividend, I'm going to raise it to the roof. Put my decimal right there. I stress the whole number divisor because tomorrow we'll talk about you need to change the position of your decimal points, so you don't want to do that raise it to the roof step first thing. First thing is check, do I have a whole number divisor? Yes. Okay, then I can raise my dividend's decimal to the roof. And then I'm just going to pretend it's 93 divided by 3. 3 goes into 9 3 times. Subtract, bring down my 3. 3, I can make one group of 3 if I have 3. My answer is 3 and 1/10. Let's try another one. So I could set this up as 1 23/100 divided by 8 wholes. My divisor is a whole number, so I'm going to raise my decimal to the roof. I can make 0 groups of 8 if I have 1. So I'm going to subtract, bring it down. I can make 1 group of 8. I can subtract, bring the next number down. 8 goes into 43. How many times? If you need to write your 8's tables off to the side, maybe I would start with something like, I know 8 times 5 is 40. 8 times 6 is 48. So I'm going to have to go with 5 groups. Subtract. Now I have nothing left to bring it down. I'm going to add another 0 at the end because I still have a remainder. And going from 1 23/100 to 1 230,000, while it adds a 0 to the end, it doesn't change the value. So then I could say, well, how many groups of 8 can I make with 30? Well, 8 times 4 is 32, and 8 times 3 is 24, so I'm going to have to go with 3 groups and subtract. Now you might notice that this problem doesn't seem like it's stopping anytime soon. If you get to a point, oops, no, that's not right. If you get to a point where you're realizing, this seems like it might not end. In 6th grade, I would like you to take your answer 1, 2, 3 places after the decimal point to the 1,000th place. If you were really good, you would go 4 places out and then you look at this 10,000ths digit and you round either up or down. So I would say this final answer is 0 and 154 thousandths, because 7 would round that up to the next number, which is 4. So I would record this as my final answer. So I should have 3 place values only if my decimal looks like it's going to keep going. And if it looks like it's going to keep going, it's called a non-terminating decimal. Terminating decimals, terminate means stop. So if it terminates on its own, like if you did 5 divided by 2, that would be 2.5, and there's nothing that would keep coming after that 5/10. So that would be a terminating decimal because you're not going to keep getting different numbers or the same number again and again. A non-terminating decimal, you're going to take it to the 10,000ths place, you're going to round, and you're going to give your answer with 3 decimal places or the thousandths place. One last thing for today. Sometimes you will get a decimal answer, and I know this one doesn't have any decimals in the problem, but sometimes you'll get a problem where you add your decimal in because it's not a whole number as an answer, and then you start subtracting, and pretty quickly you're going to recognize a pattern that doesn't seem to be ending, but does seem to be giving you the same numbers over and over again. This is called a repeating decimal because either the same number or the same pattern of numbers, like for some, like here, 1 and 8, 2, 8, 2, 8, 2, and on and on and on. If they keep going and going and going and they never seem to be stopping, you don't want to keep writing your problems over and over and over again. So we would write our final answer as 1 6/10 with a line over the 6. That line is called a repeating bar, and it means that that 6 is going to keep on going. For this one, you could write 1 82/100 with a bar that goes over the 8 and the 2, because that says the 8 and the 2 are going to keep repeating over and over and over again. And that is a way to write your final answers without having to write the same digit over and over and over again. So this only applies if you're seeing the same pattern in your decimal answer. And that's it for today.